Okay, in this lesson, we're going to go over geometric series. In the previous lesson, we talked about the sequences. Okay, a geometric series is simply taking the geometric sequence and adding them together. So if we have a sequence of 2, 6, 18, 54, etc., the series would be just taking those and adding those together. So that's the series. So you can see that would add up pretty quickly. Okay, so here's the explicit formula for the sum of the first n terms of a geometric series. Really what you need to know is the first term, you need to know what n is, and you need to know your common ratio. And then you just use this formula to figure that out. Okay, so that is a geometric series. All right, so just like we did with arithmetic series, they're going to ask to find the indicated sum for the geometric series. Now, this right here means S sub 15 means the sum of the first 15 terms. So we are going to use this formula again, but we're going to need a few things first. We know n is 15. Okay. I also need to know what a sub 1 is. A sub 1 is 1. Okay, that was easy enough. And then my common ratio, you can see here each time we're multiplying by 2. So my common ratio is 2. Okay. So now I have enough to use this formula right here. So let's see if we can set it up here. S sub 15 is equal to 1 times 1 minus my common ratio 2 to the 15th power all over 1 minus 2. Okay, so really, the 1 in the front, I'm not going to need to worry about. I can just do the top. So let's do 1 minus 2 to the 15th power. That's going to be big. I know the bottom number is going to be negative 1. Okay. All right. Okay, that's negative 32,767. Now divide that by negative 1 and we get positive 32,767. Okay, so does this make sense? This, if you were to take the first 15 terms in this series, add them together, you would get 32,767. Well, since it's doubling, it's going to increase really quickly, exponentially, right? So, yeah, that makes sense. Okay. Now, also, you might see this in the sigma notation form. So remember, capital sigma like this that you see here means add the terms together. Here is your general rule to develop the geometric sequence, and then this makes it a sum. So now when you look at what am I going from? I'm starting at when m is 1, and then I'm ending at 7. So 1 to 7, that is 7 terms. Okay? So I really want to just add up the 7 terms. But again, I got to figure out what part is what. So first, n is the number of terms. Well, 1 to 7, that's 7. You go 7 minus 1 is 6. Yep, but you're counting 1. So that's 7 terms. Okay, and then a sub 1, I don't know yet. Okay, so we're going to have to figure that out. My common ratio, I do know. It's what my multiplier is. In other words, it's going to be the thing with the exponent on there. So it's a half. because it's a half, it's a sequence that's getting smaller. So let's figure out what a sub 1 is. If I put a 1 here, that'll tell me what my first term is. Okay, 1 minus 1 is 0. Okay, anything to the 0 power is 1. So this is 24 times 1. My first term then is now 24. Okay. Hopefully that makes some sense. Now we're going to take and use this formula right here. We've got everything we need. Let's do it. Okay. So this would be S sub 7 is equal to my first term, 24, 1 minus a half to the 7th power over 1 minus a half. Okay. All right. 1 minus, if you want to do a half, you can. You might just go 0.5 to the 7th power. It's pretty small. And then the other part of this would be 1 minus a half on the bottom. So that's 0.5. 1 minus 0.5 is 0.5. So if I take this and divide it by 0.5, okay, I have my answer, 1.984375. Let's just multiply that by 24 right now. Okay, it's 47.625. Okay, so maybe I'll just write that. But again, remember, start inside the parentheses, start at the top, figure out what that is, then divide it by the bottom, figure out what that is and divide them. And then you can multiply by 24 on the outside. Okay, so the sum of the first 7 terms in this series is 47.625. Okay. Hopefully that makes sense. All right. Here's a slightly trickier one, but really kind of the same premise that we were just talking about. So let's see if we can figure this one out. All right. Now, let's look at n. Well, in this case, k starts at 6, and it goes to 20. So you might say, oh, 20 minus 6 is 14. Yes, but that's not quite right. Remember up here, look here, we got a 7 and 1. 7 minus 1 is 6, but our n was 7. So it's because you include the number 1 here. So that's important. So let's go back here. 20 minus 6 is 14, but we need to include 6. So that makes this 15. Okay. My first term, I don't know yet. I'm going to have to figure that out. And then my multiplier, r, that's right here. Okay, so negative 3. Okay. Now let's proceed to find a sub 1. So if I put this, your first term is I need to put whatever's at the bottom here of this sigma. So I'm going to put 6 in there. So what would I have? Well, I would have negative 4 times negative 3 to the 6 minus 1 power, which would be 5. Okay, let's do that. And that'll be my first term. Negative 4 times negative 3 to the 5th power. 972. So that's my first term in this series. And I'm going to add, if I'm multiplying by negative 3, this is going to be pretty big. Okay. All right, let's see how we do. Now I'm going to use this. Let's set it up. S sub 15 is equal to my first term, 972, 1 minus negative 3 to the 15th power over 1 minus negative 3. Okay. The bottom is going to be positive 4. Let's figure out what the top is. 1 minus negative 3 to the 15th power. Okay, pretty big. Now I want to take that and divide by 4 because that was my denominator. So I have 3,587,227. And I forgot the last 227. Okay. Okay, cool. Now I need to take that and multiply by 972. Woo! Big number, right? So that's 3 billion. Okay, let's write it. 3,486. $784,644. 784,644. Okay, so that's 3,486,784,644. It's a big number. That is the sum of the first 15 terms in that series. Okay, so it's a little bit trickier. Big numbers sometimes can be a little weird to deal with, but make sure that you just take your time and follow through with PEMDAS. You'll be okay. And that is it. And then you can just go ahead and do the geometric series worksheet. Hopefully that makes sense. Okay, see ya. Bye.